All right, we are now recording, and let me this is the syllabus, but it's not up to date. Okay, this is the one I used last fall. Until, was it yesterday or maybe Monday, I thought this class was going to be canceled because we didn't have 10 paid students in it. And that's what they're requiring for classes this summer, supposedly. But of course, being a 4-hour course, I was going to scream and holler if we had 8 paid students, and that's producing as many as a 10 and a 3-credit-hour course, in fact more. Right now we're 1, 2, 3, 4, 5, 6, 7, 8. We made it up to 8, but at the time it didn't look like we were going to get there. So I didn't think it was going to make, but you can thank this guy for making, because he had to have graduate. He's a Lawson student. I hate to give it away, but anyway, he had to have it graduate. So we said, well, we'll run it anyway. But then we come up with 8 students, so I think it would have run had we left it open long enough. But while we're on the subject, notice I had the adjective in there, paid students. Okay, so please, if you haven't paid already, pay as soon as you can, or at least start the process. Let them know in the financial or in the business office what your plans are, so they know that you're in the process of getting the payment done. Because otherwise, now they did this last summer. I'm hoping they're not going to do it this summer. Someone in the business office got really torqued last summer, and because they ran some classes in that interim week, we run a 1 week. I would never do, not my idea. 1 week of class, you can do a whole term. You come 8 hours a day for 6 days solid, and you get credit for that course. They had 10 people enrolled, but not all of them paid. A few of them came the first day, saw how tough it was going to be, and then decided not to take the course. So they wound up running a course with 4, 5, 6 students in it that didn't pay for the instructor to teach the course. Business office went ballistic, okay? Even though they have other classes with 20 and they got more than that, but never mind that, you know. So last summer they got all bent out of shape, and any student who hadn't paid by the first day of class, they removed them from the roll. But then they said, wait, maybe they were going to pay. So then they said, but if you re-register, then but then you have to pay by, you know. So they went through a thing of taking you out and then letting you get back in and this kind of stuff. It was put all the work on us while they made the rules. And so hopefully they're not going to go through that exercise this time, but to prevent it from happening, pay, you know, so, or at least let them know that you're in the process, you know, whatever your thing is. If you want to pay, you know, if you're waiting for a check to come, or, you know, whatever it is, let them know that you're aware and you are going to pay. Because otherwise they may remove you from the class, and then we can get you back in, but like I said, it's a headache, a lot of extra work. So the easiest way around that is to pay. Now, I'm also sort of preaching to the choir here, because more of you are paid than the people who are not here, but no guarantee that person's going to show up or not. So anyway, hopefully he will, and he'll get paid as well. All right, so that's done. So, because I didn't know that the class was going to make, but really I wouldn't have had time anyway to get the syllabus updated, so it's not. So I wanted to show you where the changes are. This is not fall. This is summer 2017. Don't worry about mini terms. That's all come off of there. But it is Math 126, Calculus 2. Are you all in the right class? Good. Okay. It's a 4-hour course. However, that would be in the 16-week term. But since this is a 10-week term, we're going to be in class for more than 4 hours a week, but so we can get the same number of hours in. Okay. The class meeting times, of course, this is wrong too, because this is a 16-week term. But Monday, Wednesday, that part's right, but it's 11 until 1:40. Okay, so way more than 4 hours a week, but we'll get it done. 11 to 1:40. And in this room, A255, in the A building, investment campus, all this. You're here, you're at the right place. This is for the person who's not here. Maybe you find this soon, but you won't know who to come to this anyway. So anyway, My name is Charles Fowler. That's the same. My email address is this. And by the way, most of the employees of the college, this will be our email. First initial, last name, no spaces, no caps, at lawsonstate.edu. Again, no spaces, no caps, .edu. Okay? Now, my phone number, 929-3449. I hate to say this, but please, later I'm going to tell you my office hours. And please, if you're going to call me during my office hours. Because right now, I'm so hopelessly far behind in clearing out voicemail messages. I don't know if I'll ever hear or see your message if you leave me one for the next year or so. I don't know how long it's going to take, but it's almost a waste of your breath to leave me a message. So call during office hours. Now, if I'm not there then, just hang up and call back in about 10 or 15 minutes within office hours. I'll be in there sometime during office hours, most of the time, but sometimes I do have to run around and take care of other things. So that is my number, so you can call anytime during office hours. Now let's talk about what my office hours are, and this is where it gets, you'll hear the sad violin music in the background because it is a really sad story here. On Mondays and Wednesdays, the day we meet, I usually I'm on campus by 7:45 in the morning, but I have an 8 o'clock class, and that's Calculus 1, so it goes 8 until 10:40. So that was just my 20-minute break that I just had there. That's why I ran down to grab a granola bar, because this class goes from 11 to 1:40. So my office hours on Monday and Wednesday are 7:45 to 8, 15 minutes there. 10:40 to 11, 20 minutes there. This class gets through at 1:40, so from 1:40 till 2, another 20-minute break. And then I start a physics class at 2, and with the class and the lab, it goes until 5:30. And then my second physics class starts at 5:30 with no break. It goes class and lab until 9 o'clock. So basically, I'm in class from 8 till 9. That's 11 hours. No, that's 13 hours with two 20-minute breaks. Okay, total of 40 minutes. And I'm going to try to eat lunch, half of it in one 20-minute break and half in the other, but I didn't get that done today. So it's going to be pretty rugged on Monday and Wednesday. But right before class, there's 20 minutes before class, 20 minutes after class. You can see me any of those times. Okay. I'll probably be here in the room most of that time. Okay. Tuesday and Thursday is a little bit better anyway. I have an 8 o'clock class in the morning, differential equations in the morning from 8 to 9:50. So my office hours are from 9:50 until 12. And at 12 o'clock, I've got a physical science class. Starts at 12 and goes till 3:30. It's got classes in the lab. So then after 3:30, I'm in my office again too. Now I haven't, because my schedule changed twice yesterday, I haven't figured out what my on and off campus hours are. I know on Mondays and Wednesdays I'm here at 7:45 and leave probably at 9:15. Okay, that's what I know on Monday and Wednesday because I'm in class every other time between that, almost. But Tuesday and Thursday, since those are, what is that? 11 and a half hour days. Is that right? No, 13 and a half hour days. Yeah, I believe that's right. 13 and a half hours on those days. To get my 40-hour week in 4 days, Tuesday and Thursday, I've got to figure out how to break that down. So I'll probably be staying here on Tuesday a little bit longer and then leaving on Thursday a little bit earlier. But I'll work that out and I'll get that on my office hours. But the best time to catch me is either right before class or right after class. I got 20 minutes on either side. Or Tuesday, Thursday, say between 10 and 12, and between 3:30 and whenever I leave campus. I don't know what time that is yet, but after 3:30. I'll just put it that way. All right. Where is my office? In this building. Oh, wait, I'm sorry. On the Bessemer campus, a building that says room A265. Now, one of you knows where that is, but the rest of you probably don't. Here we are in the corner classroom, right here. This is 255. Go out the door, take a left, and go down a half flight of stairs, and go almost to the end of the hall. At the very end of the hall, there's another stairwell here, and there's a mechanical room just like this one right next to it. In between those two, this is a big double door like this one right out here, and this exit sign here. My office is right in between those 265 right there. So it's not far from here, but it's down half a flight to the end of the hall almost. Now, this lists office hours on Fridays. Lawson, we started this several years ago when it was the big energy crisis. Gas prices and fuel prices went way up. We started not, because summer enrollment's down anyway from what fall and spring is, and weekend classes would hardly fill at all. And to cool the buildings for 2 or 3 classes just didn't seem worth it. So, and Friday classes were pretty small too. So we just went to a 4-day work week. So we worked 4 10-hour days and have no classes on Friday and no weekend classes. So the building, they shut it down, they let the temperatures go up, and they don't cool it and stuff like that. So, but they only do that for the months of June and July. So for this month, we have at least one Friday, maybe 2. I don't know when the month ends. But I know this Friday, like day after tomorrow, I'll be on the Birmingham campus from 7:45 probably until 11:45. Okay, because we'll have already worked probably more than 40 hours, but I'll be there anyway because I need to show my face over there. And then I'll be in the academic building. That's the B building, room 122. Now, again, only one Lawson student here, or some other of you Lawson students? No, just one. I was going to say, you know where my office is over there, right? If you ask questions, you can get there. I can show you on the map and stuff later if you need to get there. I'm only going to be there this Friday. If there's another Friday in May, I'll be there then, and the first Friday in August. And those are the only ones, because June and July, both campuses are closed. Now, the course description. This is not something I came up with, nor is it something anyone here at the college came up with. This was done by a committee of the 2-year college system here at Alabama and the 4-year public colleges and universities in Alabama. And they got together, called an articulation agreement, and they decided if we taught this, they would give you credit for it. Okay. So we weren't supposed to change this. And I think they've already changed it on the system. But when I first did this, they misspelled 3. They left off the HR and had, this is the second of T courses. I went, I'm not going to write that in the syllabus. I'm not going to let that be in my syllabus. So I did change that, but I think they've corrected by now. This is the second of 3 courses in the basic calculus sequence. Topics includes vectors in the plane and in space, lines and planes in space, applications of integration, such as volume, arc length, work, and average value, techniques of integration, infinite series, polar coordinates, and parametric equations. And a partridge in a pear tree. Not this. That's a lot. And it's not a reasonable order either. Okay? So I'm going to take a little pause here. I don't usually do it at this point, but I think I will. Mark this here. And one of you have a book, right? But for those, and like I said, if you have a different text, obviously you took Cal 1 somewhere, if you still have the text for that, bring it and I'll show you what chapter you're going to do. Because basically, I've hardly found a dime's worth of difference between the text. Yeah. Yeah. And who's the author? You remember? Huh?
Yeah.
What is it?
Yes. James Stewart.
Oh yeah, right. He's a pretty good author. somebody, there was something about it. I bet you this is a real old version of it. But let me see, I bet you get one back here. This is the old version.
Yeah, that's the whole version.
Yeah. But I bet you the table of contents has hardly changed. That's almost exactly the inside cover of our book. You can notice not only a different author, it's a different publisher, but so many things are the same. But let's just see. In our book, this is called Pre-Calculus Time Review. Limits is chapter 2, derivatives is chapter 3, application of differentiation chapter 4, intervals in chapter 5, applications. They're almost the same. Not exactly, but those first 5 chapters and I think even 6 chapters are almost identical. You know,
So will we have something like a website?
I don't require you to do that. If you want me to set one up for you, I can. If you like that. Oh, wow. I was expecting you to demand that. Okay. I don't care for the sign either. Okay. But you see, I bet you your book will go along very, very closely here. Any places deviates, ask me about it. I'll show you. I'll find it. So I just want to point that out. I'm not a big enough fan of book publishers to want you to buy another book. So if you have your old book, bring it and I'll show you what we're doing. And the calculus is the same. I mean, how they present it will be a little bit different. So, where was it going on this? Oh yeah, I was saying how the order here is very different from what the order is here. In fact, we're starting with integration. And basically applications of integration. And as I was asking Richard first, he said we did, see I had him for Cal 1 this past term, and I couldn't remember, it's been so long, 4 or 5 weeks, you know, since we finished it, how far we got in it. If I'll poll y'all and see where you feel comfortable. But we'll start somewhere in chapter 5, and where I tend to start is in what we in this book is 5.7 substitution. Did y'all do that in Cal 1? Do you remember? You did do it. Okay. How about the rest of them? I don't think you did you? I don't usually get that far. Do you remember in yours? Yeah. Okay, so what I'll do then, let's just plan to start with substitution, which I count as a technique of integration. That's why I start there. And since this calls for that, that's why I arbitrarily chose to start there. So we'll start in this book in 5.5, or 5.7, or in whatever book you are, wherever they talk about substitution. It'll be a review for some of you, and we'll move on from there. And substitution is fun, and it won't take us long to do that. Okay? And then the next chapter in this book, after the end of 5, is applications of integration, which is where this one says it begins right here. And then they mention volume, and that's right here in 6.3. Arc length, that's, I don't see arc length particularly, but, we'll do that kind of stuff. Work and average value. Average value is 6.2, and 6.5 is work and energy. Okay, so we'll have all those things. Then next is techniques of integration, which I counted the substitution as one, but I'll teach it with the applications. But then techniques of integration is chapter 7 in this book, and that's what we'll do next. Now, I remember now. In this book, and I don't know why, I don't think all the books do this, Stewart probably doesn't. This has chapter 6 is applications of the integral, then it does techniques of integration, and then they do additional further applications, which basically uses some of those techniques you just did. So that's why they put it up. And that's where the arc length is in chapter 8. Okay? And then chapter 9 in this book is Introduction to Differential Equations. Well, guess what? That's a different course. So we skipped chapter 9. Okay, you don't see that on here either. Chapter 10 is infinite series. There it is. And chapter 11 is parametric equations. There it is. Polar coordinates. There it is. And conic sections. So we skipped the conic section because they're not listed here. Chapter 12 is vector geometry. And vector geometry would then be vectors in the plane and space, lines and planes in space. Okay, so you see the names here are not in the same order we're going to do. We're going to do one technique of integration, we're going to do applications of integration, more techniques of integration, more applications of integration, then infinite series polar coordinates, and not necessarily, infinite series polar coordinates, parametric equations, and vector geometry. Okay. So that's how we're going to approach this. So that will be our done. So we're going to hit the topics here, but they won't be in the same order they're listed here. All right. So that's the course description. Prerequisites, basically, you need Cal 1, okay? And I think all of you have had it. Sounds like that, okay? So we won't go any more of that. The text, and again, you use whichever text you have. If you don't have a text and want one, you can do an ebook if you want to. They're pretty cheap. Or if you are going back to your school, you don't have the text you used before, maybe yours is out of date or something like this, but you're going to buy one if you go back and do Cal 3 on your home campus, then what you can do is rent this book if you want to, okay? And that's a lot cheaper, and that way you don't have a book that you don't need later on. So you have several things there. You can either use this one or use the one that you already had or will be using, okay? So I will figure we'll start with 5-7 then. Now, if any of you find anything, and this will be basically part of your assignment for next time. Now, here's the this is sort of a good news, bad news situation. Y'all aware of it? I think you probably are, and you probably haven't thought about it. But the good news is next Monday is Memorial Day, and the college is closed. The bad news is I think we won't meet. Sorry about that. So we won't meet again until next Wednesday. So you have a nice long week now that you can go back and review anything, and either stuff that you may have missed, or maybe we didn't quite get to, or in your school whenever you had Cal 1. If there's anything from before 5.7, that's where we'll be starting, then bring it, ask it, and we'll go over that, do a quick review and not do slug through the whole book. We'll just hit whatever your questions are. Okay, so anyway, so the textbook, either this one or an equivalent textbook, that's up to you, and it's Calculus, Early Transcendentals, John Rogowski and Colin Adams, 3rd edition, and copyright is 2015, which basically means that probably in a couple of years they're going to go to the new edition. Now, I'm sort of cynical about this, sort of like I am with WebAssign. When they go to a new edition, have they added some new calculus to the course? No, calculus is pretty much fixed, okay? It has been for quite a while. Oh, there may be a few things. Now, they may change the colors and maybe how they present it, correct a few errors and stuff like this, but there's hardly a dime's worth of difference between the editions. The reason they go to new editions, in my mind, this is my bias here, is that the publishers only make money on selling new books. Used books, the people who make money on those are used book dealers. The publishers aren't involved with that. So they have required new editions to come out every few years, so they're guaranteed new books. And frankly, to me, these WebAssign and packages like that, it's just another way to guarantee the students have to buy new books because they don't sell the usable package in a used book. You have to buy either a very expensive CD or you can buy a new book and it comes almost free. So I think it's a racket. But that's just my opinion. So whichever book you use, bring it, we'll talk about it and figure out what we're going to cover. Now, sounds like most of you from other schools, are y'all familiar with Blackboard? everybody, or is anyone not? Actually, in my first class, I had more than half the class wasn't familiar with Blackboard. Okay, so they must use some other package. Or no package, I don't see why. Okay. Okay. To me, the hardest thing about Blackboard is getting logged into it. Do you know how to do that? Actually, on Lawson State web, yeah, you forgot. Okay. On Lawson State web page, I can't tell you exactly how to get there, but you folks are better about finding things on web pages than I would be anyway. You know how to search it out and find it.
Student portal.
Huh?
You have to go to student portal, and
Yeah.
then it's like the third. They're set up in columns and rows.
Mhm.
It's like the third column, first row. So it's literally the very first thing. It's next to student suite and email.
Okay.
So whenever you're
That's
on the Lawson
where
State,
you click to go on.
yes.
Okay.
And then it'll take you directly to Blackboard.
Yeah, no,
Online.
then you need a login and ID.
Yep.
What I was going to say is how do you get that? Okay, I figured y'all could figure out how to get to Blackboard, but what is your login and student ID? Now, you know because you're a student here, and you correct me if I'm wrong. Okay. Have y'all been given a Lawson State email address? You have. Yes or no? Okay. Okay, maybe. Okay, I'll tell you how it looks. First initial, last name, no spaces, no caps, no nothing in between. Then you have a 4-digit number. Have all of you gotten your Lawson State student ID? Yes. The last 4 digits of your ID, those are the 4 digits that go after your first initial, last name, those 4 digits. The last 4 digits of your Lawson State student ID. Now, if you don't know that one, look at any piece of paper that you got from the system. Somewhere on that piece of paper. If you don't have a piece of paper from the system, go to the records office, admissions desk, anywhere there, and ask them for your student ID. Give them your name, they'll find it for you. If you know your Social Security, you can give them that, and they'll give it to you. So, that's the first one. First initial, last name, those 4 digits. That is your Blackboard login. Okay, just that. Your email address, then after those 4-digit numbers, at students.lawsonstate.edu. That's in your full email address. Okay. But the first part of that, before you get to the at, first initial, last name, and 4 digits of your last 4 digits of your student ID. That's your login for Blackboard. Your password is in your birthday, given as 6 digits. Okay. Okay. 2-digit month, 2-digit day, 2-digit year, right? Not 4-digit year, 2-digit year. Okay. So that's how you get someone at the door. Guns. Okay. All right. So that's how you log into Blackboard, and is that the same for your password on your email?
Yes. Or email, it's your email address, and I think you have to, I think you do, you log in with your birthday, but then it asks you to change
You
your
change it. They require you to change it on the email, but you don't change it for the Blackboard. It stays there for Blackboard. Okay, so that's how you get there. Okay. You can find Blackboard. When you find Blackboard, that's how you log in. Now, when you get to Blackboard, the home page of it, for this class, you choose this class too. The home page, there's a block up here in the upper left corner, and there's several tabs in that block. And like the 3rd or 4th one, I think, is called Content. That's where I'm going to put most of the stuff that I put in Blackboard, okay, under Content. Now, let me go back to this. Blackboard. I do not like this paragraph, but this is one they do not let us change. All Lawson State Community College students must be trained in Blackboard and use Blackboard daily to gain access to vital course information such as the syllabus, and you will be reading the syllabus every day, won't you? Saturdays and Sundays included, right?
Yes.
Memorial Day especially, okay? Every day you're going to be, okay? I think they overstated it a little bit. Okay. I will put the syllabus out there. It's not there yet because I don't have it updated yet. Okay. As soon as I get it done, I'll let you know, and I'll put it under content on Blackboard. Okay. Handouts. Now, most of the time, if I have a handout, I'm going to hand it out to you. So I don't put those usually on Blackboard. So don't look for any from me. Other classes, you may get all of them that way. I don't know. PowerPoint shows, for sure. Now, the sad news is the PowerPoint for this text stinks. Okay, it's really awful. Stuart, even back years ago when I used that, had better PowerPoint than this. And that was PowerPoint. They were still just introducing PowerPoint to, the publisher's work. This is pathetic, okay, and you'll see that later. But I do use it. So what I will do, I've got either a CD or DVD, I don't remember which it is, so old it may be a CD in here, and it has the PowerPoint on it, okay? And I will copy those onto Blackboard. They're not there yet, but I will do so. Now, if my mind's, one of the classes, either Cal 2 or Cal 3, one of the chapters is actually too big to go on the Blackboard. The PowerPoint is, and I have tried every way I can think of, but because it's proprietary, they don't let me break it up into smaller things. So I haven't figured out a way to do it. So one of the chapters may not be, but I think that may be in Cal 3. It may not be in this course. If it is, I'll let you know. But all the others will be there under Blackboard in content. Now that's going to be static. That will be what you see, what you see in here. It'll just be there. But you see, since I'm recording on Screencast-O-Matic and I use the PowerPoint, once we cover it, they'll be there then too. I blow up things so you can see them and read them better. I write on the screen. I have a ionizing pen here. That shows up. So you'll have the Blackboard with me talking and writing and everything else. So you'll have a living Blackboard. So actually, PowerPoint shows, PowerPoint will be there in two ways. Static under content and what I call dynamic under the YouTube link. Okay? So it'll be there twice. Activities, sometimes the school posts on Blackboard activities. We don't really have many activities. We come to class and do the work, So I won't be posting many things under activities. Assignments, now don't put one out there right away. It's not there yet. A research paper is due. You've been here, done that, okay? Research paper is due. I'll have that assignment up there. We'll go over it today as soon as we finish this. So that will be on there. But also, whenever we end the text, we get to the end of a section, and when we get to the end of the section, there's exercises. And I'll tell you which exercises to do. Basically, odd numbers. So I'll let you choose which ones. Or if we don't finish a section, I'll go at the end of the class and tell you which of those odd number exercises we got down to. So I'll have the assignments, but it'll all be through the YouTube video. That's where you'll see those, or hear those assignments. You won't see them. I'm not going to sit down and type them in on Blackboard. That's, to me, a waste of time. But listen to YouTube and you'll pick up where that is. Okay. Announcements. The school sometimes posts announcements on Blackboard, so we pay attention to those. Most of the time I don't, because we really don't have that many. Occasionally something may happen, and if it does, and I have a chance, I'll put it out there. But most of the time, if I know something's going to disrupt, like I don't know of any, I don't think there will be any, say a doctor's appointment gets scheduled for this time period, then I'm going to let you know as soon as I know about it. I'm not going to necessarily just put it on Blackboard. I'll let you know. Now, if there's a car accident on the freeway coming in and I can't get here, which usually I'll get here by this time, the 8 o'clock class will be an issue, but not mine. I'm not going to have a chance to put it on Blackboard. So most of the time, I'm not going to put an announcement. But if there is a need for it, I'll put it there. Grades. Now, as soon as you turn things in, I will try to get them back to you as soon as possible. And right now, I can almost guarantee you I will get no grading done on Mondays or Wednesdays, okay? In either of my 20-minute breaks, I will not be grading any papers. I can almost guarantee you. But on Tuesdays and Thursdays, following when you turn it in, that's when I'm going to try to get most of the grading done. And hopefully I'll get it posted that same day, okay? Now, this week and any other Fridays that we have, if there's another Friday in May or in August, I use Fridays to grade and get Blackboard called out. So it might be then. However, let me say this. Beginning sometime after the 4th of July, they usually open fall registration. Fall registration is our biggest registration. And the last time I checked, I had about 450 students listed as me being their advisor. Okay. Now, I don't advise them all. They usually do most of theirs online, but I do a lot, and a lot of students who I'm not listed advisors, they come see me or they get sent to me or whatever. They're advisors on the Birmingham campus, so they send them to me here. So I do a lot of registering and advising. So July, the grades may slow down. Probably soon will be weekend before I'll be able to catch up with grading. So don't look for them the next day after July. I'll try to get them done, but if I can't, hopefully I'll get them done by the next weekend. Okay, I do not like this next sentence. Failure to use Blackboard could severely damage your ability to pass the course. It's such a negative sentence. If I were writing this, which they don't let me change it, I'd say the proper use of Blackboard could enhance your ability to do well in the course. That's a lot more positive, and I think closer to reality. They've got it there. This one's ridiculous. See the schedule book. Okay, we haven't had a schedule book in years, and yet they haven't changed this, and they won't let us change it. Okay, so forget that. And then I don't like the last sentence. Students should always check Blackboard the announcement page prior to coming to class. Why would they write that in there? What is the comma clause that they're sort of implying there? In case class has been canceled. Okay? And yeah, I guess that's pretty reasonable to say, but let me say to you now, if there's any way possible, I'm never going to cancel a class. Okay? If anything comes up, I'm going to let you know way ahead of time. I'm not going to just post it there, unless I get, I don't want to say deathly ill, but so bad I cannot drag myself into campus. If I'm that bad, I don't know if I'm going to say, dear, please bring me my computer so I can put it up on the Blackboard. I think I'm just going to be out. Okay, so I resent this. I mean, that almost sounds like in case the instructors just decided not to have class that day. Not going to happen with me. Okay, if I can possibly avoid it. Okay, so I shouldn't go on like this. Okay. All right. What are the student course outcomes, learning outcomes? Students will apply definite integrals to volumes, arc length, work, and other applications. If you notice, that is basically the description of Chapter 6. Okay? I'm just assuming Chapter 5, like I said, we'll start with substitution method, but go on. Students will use different techniques of integration, such as integration by parts, trigonometric substitution, partial fractions. I throw in substitution there, but actually I do it up with the first one. That's Chapter 7. Students will work with infinite series. And by the way, this one up here, number 1, that's 6 and 8, okay? Because one's applications, the other's further applications. Okay, Chapter 9 we skip completely. Chapter 10 is infinite sequences and series. And by the way, and y'all don't have your books anyway, but let me just say this quickly, go back to it. We're going to hit substitution method and probably do a little bit about transcendental functions because those are important. Exponential growth and decay, maybe just briefly go over that. And then do Chapter 6, okay? Then we'll do Chapter 7. And by the way, we may not hit everything in both of these. Chapter 6, pretty much everything. Chapter 7, I'll touch on improper integrals, which is 7.7, but I'm got to go back and refresh myself. I don't think I'm going to test you on that. Probability and integration, I'll go over the principles there, but again, I probably won't test you on that. And numerical integration, I think we do hit that. So that is sort of important. So there will be some sections in some chapters we may quickly go over, like a PowerPoint slideshow, and that's all, but with no working any exercises. But I'll hit that as we get there. In Chapter 8, the further applications, arc length and surface areas for sure, fluid pressure and force, that's for sure. Center of mass really is important in some areas. Are any of you mechanical engineering? You are? Okay. I may not do a full job on that. It's a good thing. It just takes a while to do. But y'all going to talk about moments and maybe some of the other engineering too. There's going to be several places you'll use things like that. But frankly, they have their own ways of doing it, and they don't necessarily do it necessarily the way calculus teaches it. They do it a lot more engineering-like. Okay, so I won't feel too bad about it. Taylor polynomials, I'll definitely introduce you to those, but you're not going to be responsible for them. So basically, in Chapter 8, I think it's just 8.1 and 8.2. Chapter 9 we skip completely. Infinite series, sequences and series. We just do 10.1 and 10.2, sequences and series. And then Chapter 11, parametric equation, polar coordinates. We skip the conic section part, so basically 11.1, 2. We'll go over this in a minute. But you see, we're only doing, when we read all those things and said all those chapters, no way in 10 weeks are we going to be able to cover all that. So we'll be covering portions, and some of those will be grouped together for testing purposes. Okay, I'll go over that in a minute. In fact, the very next thing. So we will be doing these things like solving, working with infinite series and sequences, solving parametric equations and using polar coordinates. Use vectors in the plane and space to define lines in planes and space. That's Chapter 12, or at least the first part of Chapter 12. Cal 3, at least on the 2-year college system, starts with quadric surfaces, which is 12.6 in this book. So that's why I say the first part of Chapter 12, because Cal 3 begins with the very next to the last section in Chapter 12. So the books don't conform with the 2-year college system, but we come as close as we can. Okay, so that's basically the course. But then one more, students will research and write on the topic or computer applications in calculus. Okay? Now, what are the competencies? And this is where what I was just talking about is mentioned. Okay, we'll start in Chapter 5 and cover substitution. Okay? And then 6 is applications of integrals. So that little bit we do in 5 and Chapter 6, that will be covered in one test. Now, let's do a timeout here. I want to poll you. You get to choose here. Do y'all prefer in-class tests or take-home tests? Take-home? Really? Wow. This class is really unusual. No, I'm just kidding. Okay. Most people give an option. We'll choose that. And frankly, I think it's closer to real life, because if I make the test easy enough for you to finish in an hour, I'm not really feeling like I'm testing you in calculus, okay? But to give you the types of things that you need to know, it's going to take a little more work on your part, and you really do need the time and opportunity to look things up and follow it and stuff. So really, in real life, you're not going to be tested on things. Someone's going to say, here's a problem, fix it. Find the solution. Find the answer. What do we need to do? That's what I want the test to be more like. Okay? So, we'll do take-home tests. Okay. So 5 and 6, the last part of 5 and 6 we'll do. The parts we covered in Chapter 7, now I didn't write down which ones those are, but I'll let you know when we get to the chapter. Then Chapter 8, further application of the integral. Notice there's no assessment listed for that. 10, infinite series and sequences. No assessment listed for that. For Chapter 11, parametric equations, polar coordinates. Test on Chapters 8, 10, and 11. So these three will go together. Chapter 9 is differential equations. That's a different course. So this is 8.1 and 2, I think. Maybe 3, I don't remember. 10.1 and 2, I pretty much know that. And then I think it's 11.1 and 2. Let me go back and check that. I believe, yeah, 11.1 and 2, because it's no, 1, 2, and 3. Because polar coordinates are included. 11, 1, 2, and 3. Okay? Then Chapter 12, or at least the first part of Chapter 12, is vector geometry. I think it's like 12.1 to 12.5 or something like that. And then your writing competency is your research or application paper. And then the overall competency is the final exam. Now that's a little bit tricky here, especially in a 10-week term that we lose. If you think about it, losing Monday next week is losing half a week. So it's really a 9.5-week term. So suddenly, already a short term became even shorter. But we just have to live with it. So the odds are your final exam will be that last chapter test. But here's the beauty of mathematics is that everything you did here, you'll still be using down here. So this test will be not just the last test, but it will sort of incorporate the stuff you had before. Okay? So that may be your final exam for the last test.
We're not going to have to make next Monday up, are we?
No. It's state holiday. I can't do anything about that. Yeah. He's asking that because he's been in my class before. If I have a doctor's appointment or something and I make you miss a class, then I try to make that class up for you. Okay. But if it's state, the college does it, and whether if they do it, there's not much we can do with that. But if it's something that's my fault, I feel like I'm ripping you off of your tuition dollar, and I don't want to do that. Or dollars, I guess it costs a bit more than $1. All right, how do I go about grading? The research application paper is required. It will count as a test grade that will not be dropped, cannot be dropped. So this counts as a test, it's required. Can't drop that one. Now, if we have 1, 2, 3 middle tests, your lowest score on that one may be dropped. If it helps your average, I'll drop the lowest score there. If this is indeed the final, then that can't be dropped. Okay? No, I mean, it happens frequently enough, not every term, but frequently enough. I have some student come in and say, I made an A on all my tests, do I have to take the final? Yes, you do. The final examination cannot be dropped. Okay? So, because that basically is the overall competency of the class. And if I don't have a grade for that, how do I measure that? Okay, so your lowest chapter test between 1, 2, and 3, that one may be dropped, but the paper and the final cannot be dropped. Each assessment will count a 100-point scale, and when we average them up, then anything in the 90s are A's, 80s are B's, 70s are C's, 60s are D's, don't go there, and 59s and below else don't go there either. Okay, stay up there. Okay. Students are expected to attend all classes for which you're registered. If you're unable to attend a class regularly, regardless of the reason, I hear students say this, not necessarily say it to me, but I hear, oh, but this was an excused absence. Well, wait. You're either here or you're not here. If you're here, hopefully you're getting material. If you're not here, how are you getting material? I'll do all I can by recording it, putting it on YouTube, but you can't ask questions on YouTube, so try to be here as much as you can. But if you can't be and you're going to miss enough material, it's going to hurt your grade and you're going to get down in this range, it's better to withdraw than if you let poor attendance drop you into the CD range. I mean the DF range. Because frankly, for Boston students, that D would not count. You're going to have to take the course over. For you who are transient students, the D doesn't transfer. Your home school will not accept a D from us. I don't think. I've never heard of that happen. They may let you get a D on their campus, but they're not going to let you transfer one from us. So don't go there. If you look like you're going to wind up there, go and withdraw from the class. Now, sure, that may affect financial aid and stuff, but guess what? If you make a D or an F, you're going to have to take the course over anyway, which will be affecting financial aid. So I don't see any disadvantage of withdrawal. I know it can affect financial aid, but a D or an F is going to affect it the same way. So me withdrawal is better. And the D and F will hurt your GPA, and your withdrawal will not. So, all right. And it talks about nursing now and health programs. I think not you're in that. I've never had a nursing student in calculus, so I don't think so. And so see your financial service office or advisor to let them know what you're doing. But if you look like you have no chance but a D or an F, I say go on and withdraw. Okay, makeup work. Okay, with take-home tests, what does makeup work mean anyway? I mean, turn it in when you get it finished. Okay. But on that same train of thought, since it is a take-home test, try to have it done within a week. I always give you at least a week to work on the take-home test. Okay? Why a week? 2 reasons. Number one, you always have one class period to ask me questions. Okay? If you get it and start working on it, say, what does he mean by this? I don't understand the question. You always have another class period to ask me. You can ask me before that, but you certainly have another class period. Okay? Now, let's do a timeout there too. Asking me a question about a test question, okay, as in, I don't know what it means, could you explain what you're asking, or that's legitimate. I don't know how to do this, can you do this for me? That's not going to happen, okay? That's what the test question is there for, to see if you know how to work it. But I will work anything in the book. And the test questions all come from a test bank done by the same authors who do the questions in the book. So any question in the book is fair game unless it's identically the same. I've not found one yet that is the same as a test question. So anything you find in the book, whether it was a homework assignment or not, any question in the book, I'll work that. And if that helps you see how to work the test question, fine. Okay? But I don't understand what this is asking for. Yeah, I'll do that. Okay. So that's one reason. You always have one class period to ask questions. Second reason, you always have a weekend. Well, some people may be working a lot, and maybe the weekend's the only time you're going to have a chance to work on the thing. So that's why I give you a week to turn it in. If you need more time, I think that you might know this, I'm usually pretty slack about giving you time, extra time. But here's what I really want to ask you. Please do not hang on to a test and still have it when I get the next test. Get it to me as soon as you can. This is only a 10-week term. I mean, I can't return other people's tests while you still got yours out. Otherwise, the correct answers are floating around out there. Whether you know it or not, someone's eyes may fall on it, and then they suddenly get an elevated grade, which diminishes yours. That's not very fair. So I will not return the papers until I get them all in. And for you to have the tests for weeks on end, that denies the other people a chance to see what, that's not quite right. You can come by and see me, and I'll go over anything you may miss on the test, and you just won't have it to take home with you and figure it out yourself. So please get them in. Within that week, if possible, but as soon thereafter as possible. Please don't wait until the next one's already passed out, because someone missed on the first test may affect something on the second. I don't want you to make the same error twice. So please get them in as soon as you can. Okay? But I'm not going to penalize you if you don't have it in exactly 1 week. Okay. Remember, you can drop a major test, just not the final exam. Lateness, I'm going to try to, in fact, Mondays and Wednesdays I'm going to be running so ragged. I'll try to start class right at 11, but if I don't, forgive me, because I will try to make it to my office for at least a little bit, and if I get caught in my office, I might be a little late getting here, but I'll try to walk over people, get back here, but sometimes it's hard. All right, statements of discrimination and harassment. Now, I included this, I think it means that they don't use the word bullying, any of that kind of stuff. Let me simplify this. Got to sneeze first. Y'all wait. Okay, good. Poor people at home weren't expecting that word. Okay, now, I'll simplify this. We don't tolerate it. We don't condone it. We don't want it to happen. If we find out it's happening, we are going to deal with it. We'll deal with it fairly, but we'll deal with it quickly, nip the proverbial thing in the bud, and and frankly, this is either my end of my 19th or into my 20th year working here. It has always been Lawson at Western State Technical a while back. In fact, the student who sat right there in my first class came up to me after class. That's one reason I didn't get to eat any lunch. She said, "You taught both my mom and my dad." I went, "I'm old." Okay. And she said, "Yeah, I was a baby then." "How old are you?" She said, "Let's 17 or 19. Okay, but anyway. Where did that come from? I've been here for close to 20 years, at least something around there, and I have seen little, if anything, that would fall in this category. Let's keep it that way. Okay. I do remember one time. This is in my first year or two of being here. I was teaching. He happened to be one of my students. We have some great automotive programs here, and most of the time those guys are, and gals too, are pretty sharp people. Occasionally we'll get somebody whose parents are making them go to college. They don't want to do anything academic, so they want to do something like auto mechanics, and they're not really serious about that. This kid wasn't. He was fresh out of high school. He still should have been in junior high in my mind. But he just wasn't doing anything well, including the automotive. And one day at lunch, he just decided to walk across people's cars in the parking lot. He was caught. He was sent to the dean's office, and after a fair, but not very long hearing, he was off campus and never to be seen again. Dealt with. I mean, now that really didn't fall into this, except harassment by stupidity or something. I don't know. It wasn't intentional. It just, but basically, look here. Will not be tolerated. Is never tolerated. You get the idea? We don't want it to happen. Now, here's what we'd like to ask you. Because I don't see everything. I sure don't hear everything. If you see or sense or even have a suspicion something is going on, maybe not even with yourself, someone else, if you notice something like bullying or something else going on, please let us know. We don't want it to happen here. And at least on this campus, I've seen basically none of it. Have you been much on the Birmingham campus? I had a student in my first class, she said, not seen it there either. So, and I've been there most Fridays, and I've taught a few classes there. I don't see it there either. Usually when I teach there, it's in the evening or something, so it's usually a different camp one. Might come in a different set of people. All right, too much on that probably. Americans with Disabilities. Now this is a little bit, oops, I've got to update this, sorry about this. This will be a slight change because last term they changed this. I taught this in the fall, so I didn't get the change made to this one. Americans with Disabilities, let me just summarize this a little bit. As you may have already noticed by my wheeling up to you when you're talking, I'm hard of hearing. I'm old and decrepit as heavy. I don't hear well. So I'm pretty sensitive to disabilities, okay? If you have a disability, you can tell me, but I'm going to turn around and tell Dr. Renee Herndon, who's in charge of counseling here on both campuses, and she's on this campus, and she's going to get the information you need. You're going to have to bring her the documentation. She'll get the word out to all your instructors. We will do whatever accommodations it takes. She'll make that call, and she has the guidelines. She knows the stuff. On the Birmingham campus, it's Miss Janine McCoy. There are their phone numbers. Later, I'll give you the room numbers. That's in the new thing, so I have to get that updated. But it's your obligation to tell us if you need accommodation. We can't assume you do. I may see you back there squinting and stuff. I can't say, do you have a vision problem? Because the moment I do that, I'm discriminating against you, okay? Because I'm assuming you have a vision problem. But you may not. You may just squint. I don't know. So you have to let us know. I can't diagnose these things. They don't want me to. If you have a grievance, you don't think you're given a fair shake, we'll help you write us up. Okay, I mean, we go that far, is to giving you all the documentation so you can, there are procedures to do that. Okay? Now, this course calendar obviously is not appropriate for this summer, but most of these dates are. Of course, Labor Day isn't happening this term, but Memorial Day is, so I have that in there. We'll also have 4th of July, not a Veterans Day, and certainly we won't have a Thanksgiving. We don't have professional days this term either. It's going to be much shorter, but most of those important things will be in that. I'll get that updated and on the syllabus and let you know when that's done. Okay? And then when I do get that done and you're able to read it and review it and ask me questions about it, then if you will, This will be out on Blackboard. You can either pull it up, type in what you need, and email it to me. You don't have to sign it then, or you can print it off, and then if you would sign it and give it to me, and then that lets me know that you do understand everything. So far, except for the changes with dates and times and those kinds of things, any questions on the syllabus? How the classes don't go. Okay, if not, I'll let you know when I get the updates done, and once they do, you can certainly get that back to me. Now, let me go to research paper. The general instruction about you get to choose a topic. I don't assign topics. You get to choose anything you want to write about within the scope of this course. It can be a person. There's lots of people who have contributed to calculus. You'll hear me mentioned. You'll see the book mentioning. You can read up on people who have done various things with it. So it can be a person. It can be a theory. Earlier in Chapter 5 is the fundamental theorem of calculus. You can write on that. Sounds really exciting to me. But, or any other thing that uses anything that we do here in calculus. It could be a phenomenon that is explained by calculus. Okay? Just as an example, it's my understanding that one of the motivators for Isaac Newton developing calculus, he was trying to give mathematical foundation for, I always go blank on this guy's name. Blank laws of planetary motion. He was sort of a contemporary, a little bit ahead of Newton. Goodness, I can't think of his name. But anyway, he came up with this really neat formulation by observation he made of how the planets revolve around the sun. And what can I think of his name? But anyway, all he could do was show that it fit these things, but he couldn't tell why. Newton went about proving why, and in doing so, had to come up with calculus to do so. So that would be a phenomenon. You could use his, if I can remember his name, or any other phenomenon that is. Second, not Galileo. Actually, a contemporary of Galileo came up with the laws of planetary motion. Actually, it may have been a little after Galileo, and not Copernicus. They came up with the heliocentric model. I swear, I know it, and it's just blown the truth. It can be an application. I love application. Now, this is a calculus, but it was a trig class I taught one time. Had a guy who sat right back in that last desk there. Who? Kepler. Kepler's laws of planetary motion. Exactly. And I'm pretty sure that Newton either was working with him or worked after him to come up with the justification for it, and he needed calculus to do it, so he developed a whole new branch of mathematics to explain it. In a day's work, An incredible character. Okay, Newton is, of course, an incredible character, as is Galileo and several of these names, Kepler, But anyway, application. The guy who sat back there was a forestry major, actually. He was a Jeff State student, but he, had trouble with math over there. He lived in McCullough, I think, and so he drove by here every day, so he decided to come and try the math here, and he did fairly well. He wasn't a great student, but he did pretty good. He did it. And he was in my trig class, and he was a pre-forestry major. His paper, the use of trigonometry and estimating board feet of the timber stand. And it's absolutely how they do it. I thought it was fantastic. He saw exactly something that he was going to do for his lifetime, how he could use a course in. It doesn't have to be something you're going to be working on, though it could be mechanical engineering. There's tons of places you're applying calculus in that, but it could be just an interest of yours, whatever. Okay. Any other such topic about which you have an interest? I'd like you to pick something you're interested in. Now, I've added something else recently. It can be an internet application or demonstration which you find useful to the class. And by the way, let me go back. This is a little time out here. Go back to that content section. Okay, I've already mentioned in Blackboard. I'm going to put your syllabus there. It's not there yet, but I'm going to put it. I'm going to put the research paper, this thing I'm talking about now. I'm going to put those instructions there. I'm going to put my locator card, which is going to be next. I don't have it done yet, although I don't even know when I'm here and when I'm not. But then the next thing that I have in there, I have all the PowerPoints in there. That's under content too. But then the next thing I put there are any websites that either I found or students have found that they found useful for the course. And if I've been given any of those, I put them in there. Okay? And then I put the link to the YouTube videos. That's under content too. So, when I say internet application or demonstration, like I said, if a student has found one, they found it was really useful for the course. For instance, maybe the book is explaining something really wordy and they're still not getting the point across well, and then I try to talk about it and use it in the text, and it's not getting much clearer at all. But you go to and find one of these sites, whether it's
Khan Academy.
Huh?
It's a really good Khan Academy.
Khan Academy, or there's Math Vids. There's all sorts of ones out there, and you say, "Wow, why didn't they say that?" You can write on that. That if you find one that you find is very useful to the class, you can do that. How do you get a paper out of that? Well, write what was murky, what you weren't understanding, what drove you to find that. That could be a paragraph just describing that. Then what you found useful or informative or enlightening about this, how, wow, this made it seem so clear. That could be another paragraph or so. Then maybe you had to look around a while and you went to several other sites and how this was so much better than them. That could be a paragraph. You don't have to have this many paragraphs, but these are possibilities. And maybe this. I wish they'd have gone further. This got me so excited. That could be maybe part of a paragraph or something like that. So easily you can get a page or two out of that really quickly. Okay, so you can write on that. Any application, internet application demonstration you find that is useful for the class. And those sites like you just mentioned, that would be great. So what I'd like you to do this week or next week is write your name on a piece of paper. Boy, that's a big assignment, isn't it? Okay. And then write down the paper topic that you think right now you would like to write on. Okay? What I'm trying to do is get you thinking about it now so you get started on it now so you don't wait till the end of the term and give me a piece of paper that's not worth very much, okay, as a paper. So please get started. Now, since all you're going to have is on a piece of paper is your name and a topic that says nothing to do with the research paper, if you want to give me another piece of information or pieces of information, you can. I'll give you the background first. It doesn't happen frequently, but it does happen maybe once every other year or so. I'll get a frantic phone call or someone will come to me and say, thus and so is in your class, we need to get in touch with them right now, and the phone we have in the system is not working. The phone number is not working. And that really does happen a lot, because I was trying to call students when I thought the class was going to be canceled. Did I call any of you? I know I thought I called most of you, yeah. And I got y'all, but for a lot of people, I got either numbers been disconnected or no longer in service, or somebody else answered the phone, never heard of you. And so sometimes people type in wrong numbers, or your number changes, or for you that are transient students, we have much of update information, but we have some students who've been here for years, and their numbers change, but the old one's still in the system. So if you want to give me your very best phone number, you can. I'm not requiring it, but if you want to give it to me, so that if I need to get in touch with you, which is not very likely, or someone, and I'm not going to give it to another student, I'm not going to give it to Joe Blow off the street, it's going to be someone here at the college that has a very legitimate reason for needing it, that would normally have it because they have access to everything, but it's wrong there. That's the only people I give it to. And at the end of the term, it'll be shredded, so it won't go in anyone else's hands. So if you want to give me that phone number, you can. Now, if that phone number, my guess is it will be, is a cell number, and there is a chance that either that cell phone could get left at home or dropped in a well or run over by a car, or you change service or something else like this and something changes there, and you want to give me something that's a bit more permanent. Yes, sir. Hey,
How you doing?
good thing.
So I'm gonna start the glass.
No problem. Oh, is the other door locked? I forgot to check it. Okay, sorry.
No problem.
Okay, I'll be getting with you before the next class.
All right.
Okay, thanks. Dr. Bryant's our main physics teacher. I teach physics too, but he's the main one. But he's adjunct, so he's coming in now. We both have classes starting at 2. Okay. Well, actually, his starts a little earlier, so that's why he's here probably. So if there's a chance that for some reason we wouldn't be able to get you on your cell number, and you wanted to give us a good backup, like Mama's landline or something like that, you can if you want to. It's completely up to you. Or if you happen to be an employed person, and the most likely time that they'd be trying to reach you, you might be at work and maybe can't use your cell number at work, but you can take incoming calls there, and you want to give us a work number, that's fine too. Now, I don't need any of them. It's only if you choose to give me 0, 1, 2, or 3. It's up to you. If you want to include that, you can. Okay. Off of that. But I need your paper talker, at least the first one. If you want to change it, you can always change it. That's fine. I want to get you thinking about it. Now, you'll need to find at least one, but 2 or more are better, outside sources for your paper. The book has several places periodically where they'll do a historical perspective, and they'll talk about some person or some event or something like that. That can be a great idea for the paper, but that can't be your source because this is inside the class, okay? You can use that as the idea, but go outside the book to get your sources. Now that could be a book, a journal, an article, a magazine, a newspaper, any such materials you can find in the library. And this is where I get a little shaky here. Any legitimate source found on the internet. Legitimate being the operative word here. Now I tell students quite often, I think Richard had heard it, that's why he left, that during my lifetime, I was born, I say this, 1951, I don't think the internet was in existence then. I don't think it had been developed yet. Maybe the beginnings of it had been thought about, I kind of doubt it. So during my lifetime, to me, the internet is the most incredible thing that's been developed during my lifetime. Yours, you probably already started before yours, but it's just an amazing thing. 2 major problems with it, though. Maybe more than this, but I know of 2. One, at least half of the stuff on there is total garbage. Okay? Number 2, we sometimes don't know which half it is. Okay? So be very careful on the internet. A lot of people won't even let you use internet sources. I'll let you if you can find if they're good. And if you have any doubt, run them by me and I'll say, yeah, that looks good. Or, no, I've never heard of this person or this process. I'm not sure. That sounds like it could be hot. So, but the textbook is not an outside source. A good source on the internet or anything you can find in the library. Okay, your paper needs to be at least 1 word process page of text. Several things are buried in there. I don't want any handwritten text. I'd rather it not even just be typed. I want it word process. All of you know how to do that. You probably don't know how to type. But yeah. Okay, and what do I mean by 1 word process page? Well, you choose whatever format you want to use. Now, a lot of students will have some sort of header up here. I don't care if you do or not, but a lot of students will have that. And then they'll have the title and skip a triple space or something like that, and they'll start typing here. 1 word process page of text will go to the bottom of this page, and then on the second sheet of paper, come down and go at least to that line. That's 1 page of text. Because I've had students monkey with margins and spread things out and all sorts of stuff and call it a page of text, and it really isn't. That's what's required, okay? Okay, now I do want it double spaced, not single spaced. This is single spaced. I do let you and want you to double space it. I want it to be some standard 12 pitch or 12-point font, whatever you call that, which is what this is. 9s I can't read, and 26 for 4 words fill a page, that's not going to work either, okay? So, use 12-point, 12 pitch, whatever. The font you use is completely up to you as long as I can read it. I don't read hieroglyphics, I don't read Old English or Cyrillic or any of those Greek or things. Make sure it's something that's nice and readable. Most word processing packages default to Times New Roman. I don't know why. I like Arial, that's fine. Clear is fine. There's tons of great readable fonts. Keep it something that is good and readable, not hard on the eyes. Try to keep the paper less than 2 pages. So shoot for 1 to 2 pages of text. Now, if you go over, if you get so excited about your subject, you say, man, this is good stuff. I don't want to squelch that. You can certainly go more than 2 pages. But keep it good quality, okay? I've had some students, I swear that their intent, they couldn't produce good quality, so that I'm going to give them a lot of quantity. And I don't want that. I want quality, okay? If you give me a lot of garbage, I'm going to be very upset. In fact, here's how I grade your papers. When you turn it in to me, it's a 100-point paper. I can hear you now say, don't read it. Okay, no, I'm going to read it. And as I read, if I find errors or other things, you start losing points. So if you give me a lot of garbage, that's a lot of losing points, okay? So you're better off with 2 pages of garbage than you are with 15 pages of garbage. I don't want garbage, period. But please don't try to substitute quantity for quality. If you give me a good paper and it runs over, it's a good paper. You're going to get a good score. Okay. You can use any format, any standard format you choose. A lot of English classes here, at least they teach MLA, Modern Language Association. They have a standard format. A lot of scientific organizations love APA format. That's American Psychological Association format. They came up with a great format. People said, boy, this is good. Why reinvent the wheel? This is adequate. So a lot of people use that. There are others. The ones when I was in grad school, they required us to write in CBE, Council of Biological Editors. That's the one that we were required to do that. Joined several professional organizations, seems like every one of them has a different format, So you choose a format, but pick one and stick with it. The main thing is be consistent. If you start blocking paragraphs, block all your paragraphs. If you start indenting the paragraphs, indent all your paragraphs. Don't be bouncing back and forth. I've actually had students who do this paragraph in Arial and do this one in Times New Roman. Why? Or I've actually seen in the middle of a page, middle of a paragraph, they change format. Fonts. That's just being sloppy. So don't do that. Be consistent. Okay? Another place I've seen an inconsistency, especially with dealing with format, I think I know exactly what happened because I've been tempted to do the same myself, is they may make a reference up here in the first paragraph and do an open parentheses and put author's last name, comma, date of publication. Okay? And then somewhere down here, they do another reference on another source, and it's the same type of reference, but they open parentheses and put title of the article, comma, page number, or something like that. Wait a minute. If it's the same type of reference, that's 2 different formats of doing it. Now, sure, within a given format, a journal article may be referenced different from a book, different from a, Yeah, I understand that, but these could be the same ones. What I think the student has done, in this one, they use the format this source used, and down here they use the format this source used. Well, they may have been using different formats. You pick your format and do all your writing according to the format. So that's just a minor thing, but be consistent. Think while you're doing your paper. All right. Spelling, grammar, sentence structure, all those type of things will lose you points if you have errors in those. So there's no excuse for not using spell check. Every word processing package that I know of has spell check, and I think they all have grammar check on them. Use them. They're there. They're free. They're already there. You're using it. Don't skip it. Okay? Use good proofreading. And I'll just go over this quickly. I'm probably wasting too much time on this. I remember a high school English teacher that made these kinds of assignments to us, and she had this advice, and I remember even the way she said it. She said, once you've finished your paper, put it down, and she used the term, let it rest. Okay? Sounded strange. She said, pick it up a few days later, like over the weekend or sometime later, and pick it up and read it. And here's another phrase she used, with fresh eyes. What she meant by that, and I know you probably run into this too, when you're typing along and then reading here, typing, reading, that's not proofreading, okay? Because you know what you're trying to say, and you're going to read it to convey that to you, because that's what you're trying to say. But if you let some time happen, and you pick it up and read it fresh, I know, because I've done this many times with my own, I say, what in the world am I saying here? I can't remember what I was getting at, and this doesn't make any sense. I know you've done that with emails, haven't you? You've gone back and read an email you sent someone, oh no, did I say that? That's not what I meant, you know. Or texting and things like this, oh, it's awful sometimes what gets done. My wife laughs at things like, oh, I heard that your uncle died, LOL. Me thinking it meant lots of love. No, it means laugh out loud, you know. So, yeah, you've read all those things. I don't want that kind of stuff in there. But the point is, sometimes what you think you're saying here, when you read it later, you realize it's not really saying or getting to what you do. You left out a word, you didn't make clear what you're saying. So please proofread, okay? Content also matters. It's not just you're going to lose points if you have bad grammar. You're going to lose points if you have incorrect information. Because most of what you're going to write on is stuff I'll probably be at least nominally familiar with. I'm going to recognize that Isaac Newton wasn't born in 1942. It was probably like 1642, you know, or something like that, you know. So I've had people, not in this course, but write on Pythagorean theorem, and they get it wrong. Or, you know, some other thing that I know what they're trying to say, I also know they're not saying it correctly. So content also matters. So pay attention. Be careful in your writing. Be consistent. The paper is due, drop dead date on it is the last day of class, not counting finals, last day that we're in class, having class, before final examination week. But please don't wait until then to turn it in, okay? That's why I want you to pick a topic now, okay, so you can start thinking about it. You got a week before you come back to class, a long weekend. Use that weekend. Start looking for sources for it, you know, thinking about what you want to say. Start writing on it. Believe it or not, you not right now have more time to work on the paper than you ever will any time later in the term. How many of you have a test due already? Homework assignment. You know, you don't yet. That's just beginning. This is the best time to get started. Okay? If you turn it in after the last day of class, you lose points. Okay? If you turn it in earlier, as in the month, now this is things I've got to change, the month of May, which is not very much time, but if you do turn it in the month of May, you get 3 bonus points. You turn it in June, you get 2. July, you get 1. If you turn it in August, before the last day of, before finals begin, then you get no bonus points. If it's after the last day of class, you start losing points. So this is the carrot, there's the stick, okay? So try to get started earlier. Now, tell the classes this most of the time. As I said, I've been teaching here close to 20 years now, give or take. And I didn't start this at the very beginning, but within the first 5 years, I think I started assigning papers. So for around 15 years, I've done this. I've taught, used to be on quarter system for 4 quarters a year. Now we've been on semesters, 3 semesters a year. I typically have had between, I don't know if I've ever had 3 courses in a term. well, maybe way at the beginning, because that's before I started signing papers. Usually 4 or 5 courses up to this term. I have 6 courses this term. I've had terms where I've had 8 courses in a term, so I've seen a lot of papers. Now, most of the class sizes are usually larger than this. I'm guessing average about 15 or so. So I've seen a lot of papers for this many years, this many courses, this many things, and every class I have do this. And here's the general trend. This is not always the case. The general trend, I usually get the best papers in early in the term. And as the term goes on, the quality tends to deteriorate. Those at the end of the term, I can tell some of them, someone just sat down, maybe in half an hour, something out, didn't proof it, didn't spell check, didn't grammar check. I can tell they didn't. I mean, there's obvious things, anything we catch, and turn in some real garbage. Now, I've actually also had that done early in the term, too, when they're trying to hit the month deadline. So they, to get that extra point, they lose 3 points by not spell checking. Okay, so not a good choice, but, you know, but generally, now I've had some real dogs turned in early, and I've had some great papers turned in late. But the general trend is always downhill, so try to get going on it early. Start it early, finish it early, get it into me early. Okay. Here's something I require note. I don't know of anyone else who does, but when you submit your paper, please attach a single page from just one of your sources. If you have 3 sources for the paper, pick one, any one, and then either print or copy a page from that source. If it's a book or journal out of the library, go over to the copy machine, copy me a page. If it's something you're getting off the internet, print me a single page. I don't need the whole article, just a page from that article, okay, or whatever you use. Any other questions? Okay, beat it to death, didn't it? Okay, all right. I'll get this corrected and put this on Blackboard under content. Yes? A little louder. Okay, I won't be using one, but you certainly, I highly recommend that you consider using one, because to me, sometimes seeing something helps me understand that thing. So if you've got one, use it. If you don't have one, it's probably not worth buying it just for this class. But I bet you in future classes you're going to probably run into one, a need for one. So not a bad idea. Now, since you're a transient student, it probably doesn't apply to you, but when I place the book orders for the class, I also put down I require it, though I really don't. That way, students who are on Pell Grant or something like this can use those funds to do anything I say is a requirement for the class. So I always put it down that it is, but it's not really necessary. But if you got one, I would definitely use it, because I think it'll help you see things and understand better. When we're doing areas between curves and things like this, it's sometimes really helpful to see how those actually look. Not necessary, but certainly helpful. Did that answer what you're asking? Yeah, okay. All right. I'm next going to just go over locator card, okay? This is what they call, what we have to post on our doors. I don't have it yet. This is not the one for this term, but I'll show you how. This is last summer, okay? Which was summer 2016. This is 17, but my name's the same, my phone number's the same, my email address is the same. I'm still in the same department, okay? Now, let me, I'll just change the date to summer 2017. Now, some things have changed from what they were last summer. For instance, my Math 125, it made last summer, but because I had a pretty heavy load and another instructor needed the course, we let them have that, so I got some office hours there. This time, everybody's pretty much packed, so I've got an 8 o'clock Math 125, Calculus 1, and it goes till 10:40, okay? And then this class, so I have that 15-minute break here approximately. Today I didn't, but most days hopefully I have 15 to 20 minutes there. Then this class I had last summer, I do this summer from 11 to 1:40. And then another 15-minute lunch here. And now this summer I've got Physics 201 now. There's still a physics class with a lab. And one thing they did differently this time, they are wanting to have an hour and a half lab, whereas last time they had an hour lab. So it was 4 to 5, now it's 4 to 5:30. So at 5:30 begins my second physics class, which this time is Physics 202, not 201. 201 is up here. And that goes from 5:30 until 9. There's class and then lab. So basically, that's my Mondays and Wednesdays, 2 20-minute periods. Okay, my Tuesdays and Thursdays, Tuesday and Thursday, last summer this class didn't make, this summer it did. Well, it really didn't, but I have one student who needed to graduate, so I'm teaching a very small class on Tuesday, Thursday, differential equations, and it's going until 9:50. And then 237, linear algebra, didn't make this summer, it did last summer, so that's where I have my office hours, from 10 until 12, okay? This one, last summer my physical science didn't make. This summer my lunch is going to be up here, so starting at 12 will be physical science, and it'll go till 3:30. There's class and then lab. Now, what time I leave, I don't know, because I've got to figure this out, because right now I'm having, 14.5-hour days on Mondays and Wednesdays. And I've got to get the rest of my 40 hours on Tuesdays and Thursdays, and that's going to be a lot shorter. I'll probably do closer to a full day on Tuesday and as close to a short day as I can on Thursday. So I don't know what the office hours will be then, but that's what it will look like. Mondays and Wednesdays are going to be the same, Tuesdays and Thursdays the same, except for my leave time off campus on Thursday will probably be earlier than it will be on Tuesday. Okay. So I'll get that done, and it'll be under content too. So you'll always know when my office hours are. So you'll know if you are going to call me, when to call. Because don't count on me hearing voice messages. Not until I get the ones I've got cleared. Okay. One more thing I need to do before we actually get into math, and that's safety. Because we have to think about safety all the time, so I find the best time to do it is at the beginning of the term. Most of you don't have books anyway, so let's talk about safety. There's 3 areas of safety I want to address or talk about. What is this? My voice carries like a load of bricks. What 3 areas of safety do you think we need to think about? Fire. Fire, and I'm going to include that in a chemical spill. Anything that happens inside the building that could be hazardous. Fire, chemical spill, something like that. What do you do in case of fire? Well, before we do that, let's narrow the scenario a little bit. Let's first say, what if the fire initiates in this room? My computer explodes. Hopefully that won't happen. And catches my papers on fire and my desk on fire. What are we going to do? Say again. Okay, that's certainly one thing. There is something that maybe is more important than that.
Call campus police.
Call campus police, that's very important. Maybe one other thing that's equivalent to that.
Pull
Pull
fire.
a fire alarm. So let's start with call campus police. Do any of you have that in your cell phones? Not a bad idea to have. If you don't, then the number to call is 911. Okay, so I would say a very important thing. I don't even bring my cell phone to class, so I'm not wanting to talk, but I just hate hearing it buzz or something else when I'm teaching. It's distracting, so I leave it in my office. But if you have your cell phone with you, not a bad idea to have a, whatever you call it, quick call or thing.
Speed dial.
Speed dial in for campus police. In case something did happen, that you can contact. Otherwise, 911. So that's it. Okay. Number 2, you said get someone to a fire alarm. Okay. Where is the closest fire alarm? Does anyone know? Okay. Yeah. So you're looking in the hall, and that's good place to look. This is a map of the second floor. This is a map of the second floor, but everything you see on this map is part of the oldest part of the building. And this is an old building, lousy windows, concrete block walls, brick veneer. It was built before fire alarms were required by code. So no hall that you see here within sight of this door anywhere is going to have a fire alarm. So don't spend any time on these old halls. What you have to do is go down to the newer part of the building. For those who are not familiar with this, the newest part is this in here. And the reason this is blank here, that's the first floor, okay? This is only the second floor, okay? Actually, this is first floor too. I don't know why they put this in, but they did. But anyway, what you do is go out of this door, hang a left, get out of that half flight of stairs there, okay? And when you pass the restrooms, you'll see a little corridor that goes across to the, what I call student services wing. Not really a wing, but it's an area. And when you walk through there, you'll notice everything looks different. This is old, that's new. So as soon as you step through there, financial services right in front of you, the exits to the left, the cashier's windows around to the right, you're on the new part, look for a fire alarm there. There's one right this way, there's one short distance that way. Go to the closest one, the easiest one to get to, that's where you put the alarm. Nothing on this hall, go down half a flight, go across to the new part of the building. Okay, so one or two people, I like two people, go down and pull the fire extinguisher, pull the fire alarm. Somebody else, whoever got it, speed dial to campus police or dial 911. And then the other thing you said? Fire extinguisher. Where's the closest fire extinguisher?
Outside on the wall.
All right. You can't get much closer. Okay. Right here is less than 5 feet from where I'm standing right there, side of the wall. Right there is a fire extinguisher. You can't get much closer. And when you send this room, I'll go get it. You go get it. Y'all like to break the glass, don't you? Okay. Someone go get it, but don't touch yourself on the glass. And I will handle it if I'm able. I don't want you getting injured or something like this. And what did the rest of you do?
Scream and holler?
Yeah, you get out and dodge. Okay. Now, but you do it in a very careful, slow, orderly fashion. Where do we go? Well, again, we go out this door, take a left, go down the half flight of stairs, take an immediate left there, go down one more full flight, and then you head out. Now, this is not a very good picture, but it's adequate to the aerial photo. Here we are in this classroom right here. And where you go out is right down here, and then walk across this grassy area down to that big parking lot down there. That's where they want us to go in case of the fire. Yes.
Now, is that still what they're wanting us to do, or are they wanting us to do what we
Okay.
practiced that one time?
No. Okay, that's what I was going to say. That's what we're supposed to do. It was last year, fall term, was it?
Yeah, it was. Oh, and it was a
Or it was the year
weird
before
day
that.
too. It was strange
They
because
said-
not a whole lot of people were here either.
They said, we're going to have a fire drill, so listen out for it. And then they said, and we want everybody to go out the back door and meet in the parking lot back there. I said, no, you do a fire drill by doing what you're supposed to do in times of a fire. You don't practice doing something that's wrong, okay? That's not the purpose of a fire drill. I say, and so I took my class, you were in it. I took my class where we were supposed to go, and then we went down, and out. And I stopped right there and said, now, if this were a real fire, continue to that parking lot. They want us to go to the back parking lot, so we went around the building that way. They had everybody in the building going out the same doors. I thought, ridiculous, okay? This is not what you do. It's not what you should practice doing. So, and someone yelled at me. I said, no, you do not practice wrong behavior. Practice what you're supposed to do. Then we'll go to the back and we'll have our thing. We didn't walk all the way down here. We just went to the back parking lot. But it was ridiculous to me to practice us a drill, we'll still go out the door, but we'll go wherever they tell us to go. Okay? I will refuse to practice bad behavior. Okay? What's the purpose of a fire drill if you're going to show people how to do something wrong? That's just not worth it. Okay. So as soon as you hear the alarm, or once we've covered everything we need to here, then we proceed out. Now, what you do when you get there, you don't say, hey, no more class today, I'm out of here, okay? Nothing like that. You stay together as a group. Some people may be pulling fire alarms, some may be fighting the fire here, whatever. You wait till we all get together down there in the parking lot. I will carry, the only thing probably I'll get out of here will be my roll book once I have you in the roll book, and I will call roll down there, okay? Anyone that's missing, either myself or some fire professional, is going to have to come back into the building looking for you. When you've wandered off to talk with a friend or try to head home or whatever, don't do that. Stay together so we can account for everybody. And then they'll either dismiss us, tell us where to go next, whatever. Only after we hear the official word do we split up. Once I've got the roll and you say, well, I want to go talk to this, I'd rather sit in my car, it's raining, and stuff. Okay, yeah, just as long as we know where you are. And we can get back. So that's in case of fire or chemical spill, anything inside the building. What's another safety issue?
Tornado.
Tornadoes are something weather outside. It doesn't have to be a tornado. Severe thunderstorm, straight line winds, anything that's happening outside, what do?
We exit the classroom and go to the nearest bathroom.
Okay. Instead of going down and out, we go down and in. That's basically the only difference. And again, we go out this door, take a left, go down the half flight of stairs, take a left, go down the full flight, but rather than go out of the building, you go interior. That's as low as you can go in this building, right down there, go interior. Now, in case of a weather emergency, straight line winds, whatever, tornado, you want to be in a low interior area, and the greatest strength is going to be in the corner. Got a right angle there, that's the greatest strength. Middle of a room, not good. Middle of a wall, okay, not as good as in a corner. Not everybody can get to the corner, so just be smart about it. Don't be mean, okay? And do not. So where are the safest places? One of the safest places is right when you get through that door on the first floor. It looks a lot like this. The restrooms are right there. Very small rooms, walls are close together, lots of angles. That's maybe not the ideal place to spend a couple of hours, okay? Especially if power goes out. And with weather emergency, quite often it will. I just remembered something I forgot about fire. I'll come back to that in a second. So if you don't like the restrooms, probably the next one would be just below where this corridor is actually the dean's office. And again, it's a fairly small office. It's either Dr. Davis, the Dean of Academic Affairs, Dr. Pruitt, who is the Associate Dean, or sometimes Dr. Briggs in the summer is over and uses that office. If anyone's there and they don't mind you coming in, a pretty safe place and fairly comfortable place, and the walls are close together and some corners there. However, most of the time that door's locked, so don't break in. Okay. Next to that, on the right, is a big classroom. It's probably as big as this room, not shaped like this, but a pretty good sized classroom. Not ideal because there's not a lot of wall space, but as long as you're near a wall, especially a corner, that's pretty safe. Not bad. Next to that, you go into the library. In the first floor, there's a glass door in the hallway here. And just inside the library, there's a computer room. Again, that one, the walls, is a smaller room, so the walls are closer, and that's a pretty good safe room to do. Right next to that is what I call a reference room. It's where the atlases are and those kinds of things. It's also in the library. It's a little bit bigger than the computer room, so that way maybe not quite as safe. The other thing is it does have bookshelves in there, and they could topple. So you sort of either be near a corner, you're going to be near a bookshelf, or being in the open, away from a bookshelf, you're in the middle of the room. So probably not ideal, okay? Really one of the better places is the hallway. And here's the reason for the There's no corners, so that's bad. But the walls are relatively close together, and they have emergency lighting on both ends. So if we do lose power, at least you have light there. And you can sit up against the wall, lean against the wall or something, and be pretty safe. Okay? These other spaces here that have more corners, they don't have emergency lighting. Now here's the thing I forgot about to say about fire or chemical spill, but it also pertains to this. The other reason you stay together, you do on this too, you stay together until I get down and call roll. Here's the other reason, not that I might be fighting a fire or something else, all of you look pretty able today. But what if you go skiing over a weekend or something like that and twist a knee or something like that and you're on crutches or in a wheelchair? Then I'm going to be with the last person, if you whoever it is, and making sure that person gets out safely, because there are no elevators in the building, okay? There are only stairs. So I'm going to be helping and making sure you get down safely, people don't jostle you, make you fall, and you can take your time doing it, and I'll be with you. Now, people in a wheelchair, the only way they can get to this room, they can't go down these stairs, and they can't come up these stairs. So they have to go not here, here, this stairwell back here, and this far, far corner of the building, about as far as you can get from this room, is a lift that goes up and down the stairwell. Okay? If power goes out, that's not useful. That can happen in case of fire, it can happen in case of weather. If we lose power for any occasion like that, then that person cannot get out if he's in a wheelchair, he or she. In that case, I might be calling on some of you able-bodied people to help me help that person get down this half flight of stairs and out. If there's some way possible to get them out of the building as safe as possible. They may not be able to join us in this parking lot, nor would they want to, but if I get them out safe, secure, with someone else, then I'll go down and join you. So that's the reason. That would be, for either of those scenarios, I'll be the last one there. So please don't leave the building there. Okay? And I may call on you to help if we need to do so. Okay, I think we've hit those two areas of safety. There's one other.
Active shooter.
Active shooter. Unfortunately, nowadays we have to always think of this too. Now, what do we do in case? Now, guess what? Y'all hear better than I do, right? So you're going to hear it first. If you hear anything that sounds like it could be shots, let me know. What do we do?
Call the police.
Okay. Anyone with a cell phone, that's why it's really important to have that speed dial in there for campus police. And if not, definitely 911. We used to have a phone in this office back here, they took it out. When they had that, I knew I could call the campus police immediately. Okay. But call one of those two. Y'all are gonna have the phones, I'm probably not, so you call. Okay. What else do we need to do?
Start locking the doors.
Okay, start locking doors. Now, I'm the only one that can lock this door. Because there is no button or anything else to lock this, I have to physically go outside the room, get the right key, and lock it from the outside, then come back in. I don't want you closing the door and locking it out. I can't get back in, but we don't need that waste of time. Come back in, pull it closed, then it's locked from the outside, we can still get out. Okay. So what do we do about this door?
You have to go to the other
Yeah,
room.
don't do anything with it.
Yeah.
This does have buttons on the edge that do locking. Okay? I just did. It locks it from the inside, but not from the outside. This is so whoever's in the office is safe, not whoever's in the classroom is safe. So that's not a good move to make. You just want us in and he can still get in. And say he goes back to you. There's a middle door here. Don't want to talk too loud because they're having class right next door. That middle door has a deadbolt. It's only operated by key. I don't have a key for that. So that one's not good. But the next door, the one that goes into that classroom with that second office, that one has a button just like this, and it locks from the outside of that one, not from the inside. So that's the one to lock. Now right now, the outside door here, that's what I had to come through here. I forgot close that little door. You can shoot through glass. You can't shoot through the door. So close this door. This one's closed, but we still got a glass here. So what do? We turn off the lights, turn off projectors. We all get back here in this corner because you can't shoot through concrete walls very well. Or if you have a bazooka, we're all dead. Okay. So we're here, we're quiet, and we stay there until we hear an all clear from someone who is in authority. Then we get up and they'll have keys and come and lock us and get up. Sorry we have to do that, but we have to think of things like this before they happen. So, any questions on any of the safety issues? All right, good deal.
Also, we went over to, I want to say last time, that if there was a breach, that the active shooter actually came in, that
yeah.
we would all convert, or, you know,
Okay.
if there's the, you know,
Okay.
or whatever, different tactics.
Yeah, and those are good things to think through. And I'm glad you brought that up because, again, the students came up with that before. I'm not going to tell you what to do then. I'd say use your own common sense. But I'm old. I don't have that many years left, you know, so I'm going to do everything I can to get between you and the gun. And don't be yelling at me not to do otherwise. I mean, it's okay. I'm at peace. So. And, you know, I would never say let's attack the guy or anything else, but I'll do all I can to do what I need to do to save, to protect y'all. If I do something stupid, let me do it. I mean, it's fine. If y'all choose to, I mean, to me, some of the biggest heroes that have lived during my lifetime were those people on the plane over Pennsylvania. I honor those guys because some people on that plane decided to confront the terrorists. You know who I'm talking about, 9/11, and not let them turn it around and kill a bunch more people. They're going to be dead anyway. They did very heroic things, but I'm not going to ask you ever to do something like that. If I do something stupid and do it, that's fine. If y'all see opportunities, take them, but, you know, by and large, you are our future. You're the reason here. I'm pretty much past. So, but if y'all do something, and there are different theories on things, I'm not going to get into those. But don't be afraid if I do something that looks like it's stupid to you. I'm okay with it. You know, so I hope I have the guts to do it. So anyway, all right, good point. If someone's got an automatic weapon, he can get us all. So just, I would say, be as safe as possible. Okay. I don't even want to think about it. I didn't want to think about it to begin with, but they make us. Well, they don't make us. I choose to. Okay. Any other questions about anything to do with the course, the school, anything that you have questions about? Let's see. I don't think I need that anymore. So let's get to this. Okay. We decided to start in 5.7, didn't we? The trouble is, this is the old PowerPoint. I'm not sure 5.7 here is the same as 5.7 here. Let's see what it starts with. No. I think it must be 5.6 in this one. Yeah, in the current book, if you have it, it's 5. Oh, and you have the international, so I don't even know where it is in yours. So,
Unfortunately enough, it's actually in the right place.
Okay.
For once.
okay. He bought a cheap book. No, I mean, less expensive, but it just happens not to coincide.
It's not the early transcendental.
Yeah, transcendental.
Yeah.
So that section may be missing in yours, then we'll see. Okay. Anyway, we finally get to start calculus. Wow. Okay, but we got 40 minutes, 35 minutes or so to do it. Okay, from current slide. Okay. Now, as I mentioned before, the PowerPoints here stink. Okay. Why all that white space? If you did this in a class and you were doing a presentation, you would get gigged for having that white space. So what I do, because this package allows me to do this, I can zoom in, but I can't zoom in and write. So I can either zoom in or write, but not both. Okay. And actually, I want to write first. Sorry about that. Let's go back. Since none of you have a book except one, then let's start. Now, this is assuming that you know what integration is. Can anyone give me another word that almost is the same as integration?
Is it antiderivative?
Yes, taking an antiderivative, or afraid, probably is a better way to say that. That means the same thing. And the fundamental theorem of calculus basically treats these. Now, back in algebra, pre-calculus algebra, I assume you had that, you probably learned about inverse functions, right? What an inverse function is, if one function does something, say a function operates on a variable and produces another value, right? That's what a function does. An inverse function would operate on that value and give you the value you started with. So it always takes you back to where you were, and that's why it's an inverse. Okay? Like sine and inverse sine. Sine of an angle gives you a number. If you take the inverse sine of the number, you should get the angle you started with, within pi or 2 pi or something like that. Okay? Now, adding and undoes subtraction. Subtraction undoes adding. Those are inverse functions of each other, multiplication and division. Very simple things, but big functions do too. Square roots undo squares. Cube roots undo cubes. You know, that's inverse functions. Integration and differentiation are inverse operations of each other. They're not functions, they're operations. And they undo one another. So that's why integration is an antiderivative. And I'll try to, most of the time I'll ask the question in terms of antiderivatives to think you, what way do you have to reverse a derivative to do something? Okay. So anyway, integration or anti-differentiation is generally more difficult than differentiation, because differentiation, you're starting what you know, you do the operation, you get an answer. Integration, you have to see what you got and think what if you took a derivative would give you that, so you have to sort of think backwards, inverse, okay? Now, this is a sad statement, but true. There are no surefire methods to doing antiderivatives. So what we do is come up with techniques. And you start learning to watch for things, okay? And the first of these techniques is going to be substitution, okay? Which uses, and I hope if you remember your derivatives, one of the things you did after you finally got all those, how to take derivatives of polynomials and all the other things, and then you took the derivatives of product rules and quotient rules and sums and differences, all that kind of stuff. Then one of the next things you did was the chain rule. Okay. What the chain rule was, again going back to pre-calculus algebra, remember when you did I'm going blank on the word now. Composition of functions. Wow. The old gray cells ain't what they used to be. You remember composition of functions?
F of G
Of some other, yeah, F of G of X. You're taking a function and operating on the answer of another function operating on the variable. That gave you a value, and then this function operates on that. That's called a composition. Two functions composed, one with another. Well, the chain rule basically tells you how to differentiate composed functions, composition of functions. So, when you're doing integration, goodness gracious, you're having to undo a composition. And that is not always easy. The substitution method is one way that you do that. Because remember, with the chain rule, you have an inner function. Well, with composition functions, you have an inner function and an outer function. You do the inner first, and then you operate on the result of that with the outer. And then with the chain rule, that's exactly what you do. You take the derivative of the outer function, and then the derivative of the inner function, and it's a product of those two. So the substitution method then helps you do the chain rule in reverse, and it's just a method that allows you to do so. So here's one they give to begin with before we get to the rule here. What if we had the integral? Let me get my pen activated. And for those who, as I said before, Screencast-O-Matic is going to save not just everything I say and not just a projection of the PowerPoint, but anything I write on there with this thing, because it's being projected, it's doing. So here we have the integral of 2x cosine x squared dx. Now, if you're a real linear thinker, which I tend to be, one of my things would be, is this something to do with the product rule? Because this is a product of functions. Don't do that, okay? What you're looking for here, you have a function of a function. This is a squaring function, this is a cosine function. So that basically is setting up, this is a composition of two functions. Forget about that, that's just a product, okay? But this is a composition. So we look at the inner function and see if that is in any way related to anything else here. And that's where we get where the magic happens, okay? Now, they're not doing this in the book yet, but I don't see why not. So I'm going to tell you what I would do in this case. I would pick that inner part, the inner part of the most complicated part of the expression. 2x multiplied, that's not very complicated. Cosine, that's a little more complicated. And now the inner part of that, that's the innermost part of it. Let's let that be our variable. We're going to name a new variable. And you can pick any new name that you want. I wouldn't use x. T, okay. Let t equal x squared. That innermost part there. Okay? Now, next thing I do, substitution method, is then take a derivative. Now, I hope you won't find this sacrilegious or anything, but I've said this before in class, and students sort of seem to like it. I don't know if any of you go to church, but in our church, we have children's church. And all the kids go up front, and the pastors, whoever it is, happens to gather them around. They'll usually ask them some question, get them involved in it and stuff. And there's always some kid that no matter what question they ask, they answer, Jesus, good answer, in church, you don't know what he talked about, answer Jesus, So I'm going to be almost the same way here. When you can't think of anything else to do, take a derivative. Okay, why not take a derivative? It's almost the Jesus from calculus. No, that's what I'm not going to say. Okay, so there's your t. So guess what the next thing is? Then dt would be what? 2x dx, right? Because now, actually, this is a differential, not a derivative. A derivative would be dt dx would be 2x. If I've written in differential form, which puts the dx over here. You all okay with that? Okay. Now, the magic here is that this shows up right up there. There's your 2x dx right here. And that is dt, right? So let's rewrite this integral. This would be the same as the integral of cosine. That hasn't changed. But your x squared is t. And then the 2x dx is dt. And guess what? That is a integral I can do. I don't know if y'all can do it. You remember how to do your trig functions? And here's where I ask the question, what's the antiderivative of cosine t? What I mean by that is what function that when I take a derivative of it gives me cosine t. Anyone remember what that is? Sine t, exactly. So the answer to this would be sine t, but this is an indefinite integral, meaning it has no limits on it. So what you always have to do with those? Plus c. Perfect. Now we go back and plug in what t is. T is x squared. So this is the same as sine, I can't write, okay. Sine x squared plus c. There's your answer. Okay? Now how do you check to see if that's true? Take a derivative. Y'all get it? Catching on here, aren't you? So the derivative of sine x squared would be the outer function first. Cosine x squared times the root of the inner function chain rule. 2x. And there you have it. Cosine x squared. Done. Make sense? All right. So what you're looking for here, and if I'm grinding this into the ground and making something that's really obvious seem like it's more complicated, tell me, hey, let's move on. I'm fine with that, okay? Okay. Good. Here's another one they come up with. Let's see if we can do this down here. What if we had the integral of 1 plus, I can't write, goodness gracious, 1 plus 3x squared times the cosine of, they're really getting stuck in the mud on this one, aren't they? X plus x cubed dx. What would you do? Where would you go? What would you try? And this, by the way, is a 1 plus. It's not h. I realize that looks like an h. It's not. Second? Okay, this thing right here, what you want to name that? U. Okay, I wondered when that was going to happen. That's what the books always use. They don't use t's that often. They use it for parametric equations all the time, but they love to use u's for this. It doesn't matter what you name it. You could name it Sam, anything you want to. Let u equal x plus x cubed. Then u, or du, is equal to 1 plus 3x squared. Remember that from your derivatives? One more piece. Dx, okay, yeah. If you're writing it as differential form, write that dx there. And guess what this is? That's exactly this and that. So this part here is your du. So what your integral become? Cosine, and this thing here is u, and the other part is du. And that's the same integral we had before. What's that? Sine u plus c, and that would then in this case be sine of, what's your u? Yes, x plus x cubed plus c. Done. Make sense? All right. Any questions on that? All right. Now, they're going to go into a lot of stuff here, talking about composite functions and naming them And they love to name let me see if I can make sure I've got it right. The big function of a composite function they like to call capital F. Oh no, okay, back it off a little bit. Okay, let me clear my writing here so it won't be in the way. Okay, and now I'll blow this up. Boom. Okay, blew it up. Okay, the substitution method. Now, they love making this thing, and I've always thought, okay, maybe it makes sense to use this. If capital F prime of F is equal to capital F prime of X is equal to little f of X. In other words, derivative of little f, the derivative of capital F is little f. So that means the integral of little f is going to be capital F. Okay? So that's what they're doing here. Okay? And to me, I don't get a lot of inner satisfaction out of naming it this way, because then I have to stop and think, okay, this is what they mean by it. Well, why don't they just say it? But anyway, if that's the case, okay, if you have an integral and you see in there a function, okay, that the inner part is related to the rest of that function by a derivative of that part, okay, what we've been doing, but this somehow to me doesn't make it any clearer, it makes it murkier, then if the capital F is the integral of little f, in other words, the derivative of capital F is little f, then you just take the integral of this one, the antiderivative of this one, that's going to be the answer of this, because the chain rule is going to take care of that. Okay? And to me, it's far easier to see in the actual example than using this. Maybe this is clear to some people, but it is. It's absolutely correct, but I don't get any full sense of, oh, now I see it. You know, I have to think through what it's doing and say, of course, that's right. Okay. So that's what we do. But I've already spoiled you because I already told you how you do it. And it's a lot easier to do that than trying to remember something like this, in my mind anyway. So either way, you got your choice. Go for it. Now, for some reason, and I guess it's okay, they almost go out of the way to make something that I thought was fairly obvious, something that maybe not quite is as obvious. And why? Because it seemed okay to me to begin with. It's what we've been doing. And they put this in here, and well, okay. Here's how they build up to this. du is equal to du dx dx. Okay. I don't know particularly why they chose to do this, but it's not really good mathematical practice to think of it this way. But they say you can think of it this way, but really it isn't. If you look at this, and you look at that as if it was a fraction, which it isn't, it's just written like a fraction. But here it looks like the dx cancel out, you get du is equal to du, and you say, yes, that makes sense. Well, in reality, du dx is just an operator. It's not a fraction. But writing it in that form makes it look like that, and sure enough, it's a true statement. That is indeed true. And the other way to do it is think of this as dividing both sides by dx, which is not what you're doing either, and that would give you du dx is equal to du dx. Well, neither one of those things are really what you're supposed to be thinking of, but indeed that is a true statement. And that's how you go from a derivative form to a differential form, you're basically splitting the operator, okay? So that's not really what you're doing. But this du dx is the same as u prime. Remember when you did derivatives, there's lots of different ways to write it. U prime, du dx, yeah, there's at least those two ways to do it. So this is saying the same thing as that. So if you write it in that form, in other words, if you started off, let u be this function of x, whatever it was, then u prime, take the derivative of u would be the derivative of whatever that function was times dx. That's exactly what we did without thinking through all this, but indeed all that is true, so I didn't have any problem with it, so why did we do it? But anyway, let's just do a few of those just to see. Let's let u equal x squared. What would be your next then? Du is equal to?
X squared, or excuse me, 2x.
2x?
In parentheses, x squared.
No. You're just doing this. If this is true, if u is equal to x squared, then du would be?
Oh, 2x. Oh, okay.
2x dx. That's it. Okay? To me, that's pretty straightforward without thinking through all this other stuff. Just do it. Okay? It's there. How about this one? If u is equal to cosine x cubed, then, I like to do that rather than then. Actually, a double arrow actually is better. What would you do next? Du is equal to negative sine of x cubed times 3x squared dx. Perfect. Excellent. Excellent. Way to go. You just take the derivative of this. Now, you did, who said it? Who was doing the talking there? All right, good. Okay. I feel sorry for you. You think the same way I do. Okay. I always like to take the derivative of the outer function first and then do the inner. And I see the book quite often doing the inner first and then the outer. It doesn't matter. But I like doing it this way. It actually reads better to get that 3x squared in front. Because then you're not taking this as part of the argument here. But this is how I do it because I think of it that way. And actually then I would put the 3x squared after the minus sign in between that. And then it looks like the minus goes with that. It really doesn't. So you have to keep up with what's going on, but you did it absolutely correctly. And they wrote it in the book, believe it or not, minus 3x squared sine x cubed dx, which is absolutely correct as well, but written this way, there's a little bit of maybe ambiguity. Is this the argument of sine or not? Writing in front is obviously not, but you write it in between the minus. The minus went with this went with that, but still, this is another way to write that. So, the order. Now, someone was asking about Webasine, right? Early? Okay. When I'm teaching even Math 100 or 112, 113, I've tried to use Webasine before. And a lot of those things, really, you have a best answer, usually. You know, it's the most obvious way to write the answer. But you can write it different ways. And if you're doing Webasine, that's wrong, even though it's a perfectly correct answer. So I spent most of my time trying to explain to students, no, you got it right. They just wanted it in this form. No, you didn't get, okay, I know they took off points. I'll have you give you the points back. Stuff like this, you wrote it in, fine, yeah. When you get to calculus, there can be literally, I think sometimes dozens of ways to write the same answer perfectly correctly. And figuring out which one they're looking for, you can spend half your day. If you have 3 chances to get it right, you may be right every time, and they're still telling you you're wrong, and you wind up missing it. So I say, hey, and what's more, students get so frustrated thinking they got it wrong and then trying something else that's wrong and they had it right to begin with, you know. So that's why I don't really like these single answer things. I think they're rackets, but if you love them, I'll do them for you. I'll do whatever it takes. Okay. Sorry, I was on the soapbox. All right. Now, this is not a bad, this is again one of these things there. I guess they think this is going to simplify it, but really it's a pretty good way to look at it. If you can break an expression up that's in an integral, and you see f is operating, some function is operating on something, and the rest of what's in the integral is a derivative of that something, even though they may have written in various places, if you can piece them together, then that's when the substitution rule comes into play and really is a piece of cake. I mean, it makes it so simple. Now, some functions are not real easy to see, though, that way, and we'll do all sorts of little tricks to help us, but that's the whole point of the substitution rule. That's it in a nutshell. Okay? If you can see a way to divide a problem up in that equation is sometimes called the change of variables form, which to me is substitution. Okay? And they're going to start easy here on some of these examples, and after a while they're going to get a little bit, they're going to introduce some things that are not quite as straightforward, but you can see how to make them straightforward. So let's start with a straightforward example. Okay? I don't believe we have a slide for it yet. Well, let's see. That is, yeah. That's what we're just saying. Again, the slide set and the book are from different things, and this is exactly what was just there. Oh, no, the only, sorry. This is it for definite integrals, so forget that. Let's go back to where we were. All right, let's do example 1 here. Here's the integral. 3x squared sine x cubed dx. 3x squared sine x cubed dx. Boy, it's almost like we were just here, wasn't it? How would you begin? And they do put these in parentheses, which is not a bad idea. And again, here's what I look for. The innermost part of the most complicated function, here's its derivative right there. Right? There's the innermost part of this most complicated part of the function. The innermost part of it, there's its derivative. Substitution! Okay, it's yelling for it. Okay? So, how would you proceed? Let u equal x cubed. Then, du is equal to 3x squared dx. Fantastic. And now you see, just like before, bing, 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 there's your du, and this can be, so this can be rewritten as the integral of sine of u, if I could write. Second? No, du. Okay, yeah. You're doing the integral first. Right? Here's sine of u, because u was x squared, and then that part here is your du. Right? That's what we had down here. And now we do this, and what does that produce?
Sine of x cubed.
Second? Negative cosine. Okay. Now again, for those of you who have been away from it a while, remember integration's the antiderivative, taking derivative in reverse. Your trig functions. Derivative of sine is cosine, but derivative of cosine is negative sine. Okay? Now, is that new or fuzzy or a long time passing or something you remember well? Everybody got it? Okay, good. Okay. I was going to say, here, I'll probably say it anyway. If I think about the graph, I like to think in terms of graphs. Graph of the sine function. If you look at a sine function here, you know it starts at 0, goes up and down. The derivative of this looks like 1, doesn't it? The derivative of that is 0, right? Horizontal square. The derivative of this is, I have to draw it. Let me draw it. I'm polluting your minds with my weird way of thinking. This is basically a sine function, right? Okay, ugly one, but the sine function. Its derivative is the slope of the tangent line. Looks like a 1 to me, doesn't it? Slope of this. And by the way, this is at 0, pi halves, pi, 3 halves pi, and 2 pi, right? And then it just keeps repeating there, right? So the derivative here is 0. Derivative here, derivative of sine here would be 1. Derivative of sine here would be 0 because the slope is 0. What's the derivative look like here? Negative 1. Derivative here, 0. Derivative here, plus 1. Now let's draw the cosine function here. Cosine function starts at 1, goes down to 0, goes down to negative 1. This derivative here was negative 1. This is at 0, pi halves, pi. That's a negative 1 here. Goes up to 0. That's here at 3 halves pi. And then it goes to 0. Yeah. That goes to 1 again here. So you see the derivative of sine is cosine. That's the derivative. That's the graph of the cosine function. But then looking at the cosine function, what's the derivative of this? 0. So that would be a sine. That's fine. Well, what's the derivative here? Negative 1. So that would be down here then. So the derivative of cosine is negative sine. The derivative of sine is cosine. I don't know if that's helpful, but to me, think back of the graphs and know that I got the signs, the SIGN signs right anyway. I hope so anyway. All right, so that's negative cosine u. Sorry, that was a outtake there. Let me erase this so it won't be as ugly anymore. It'll still be ugly. Okay. Okay, finally. Now we got the negative cosine u. Are we through? What? Plus c, yes. Don't ever forget when you have indefinite integral, put that plus c in there. Are we finished now? No, we started with x's. We need to end with x's. So what do? Negative cosine, and u is or u are? No, never mind. What? X cubed plus c. And usually they put those in parentheses. Good deal. Now, they won't always, but I like putting this in parentheses here. Because if you write the sine of x cubed, you might think incorrectly that means sine cubed of x. And it doesn't, because then you put the cube there. But putting in parentheses tells you, no, this is the thing you're taking the sign off. You're not taking the sign of x and cubing that answer. You're taking the sign of x cubed. So I like to put the parentheses there, though you won't always see them. But you have to be careful of what that exponent belongs to.
Just letting you know it's time. I know you're kind of on a tight schedule.
What's that?
It's time.
You're kidding me. Just when we're having fun. Well, we always have fun, don't we? All right. We'll start next time with a little bit of a nuance here with example 2. Let's see if we did enough for you to do any homework exercises. Notice how Richard said it was because of my tight schedule. Not that he wanted to get out of here, but yes, okay, wipe it. Okay, never mind. Okay. I think you can do, yes, for sure you can do any of the odds. This is on page 311, 1 through 5. And then I think you can, well, let's hold off on the others and we'll do those after we do a couple more. Okay. If you want to come take a picture of mine, you can, or if you know you're going to get a book soon, you can do that. I used to go down and make copies, but now that everybody got phones that can take pictures, you can do that. It's a lot easier, probably, and faster and cheaper, and, well, you paid for the cell phone already, so. The only ones you have to do there, but you can take a picture of the whole page if you want to as well. Okay. Never want my picture. They only want the picture of my book. No, I'm just kidding. Don't you dare. Okay. No. Yeah. Just 1 through 3. 1 through 5. It's 1 through 5. Oh yeah, you don't have the back of the book, so it doesn't help you out. Do any of them you want to. Knock yourself out. Okay. Yeah, of these items here. Pretty simple stuff.
I thought it was a good class.
What's that?
I said